In this video, we're going to talk about exactly how glaciers move, the speed at which they move, and the glacial budget, which has absolutely nothing to do with money, but instead all about ice. There are two possible ways that glaciers can flow. The first of which is called plastic flow, which is where we have sheets of ice that are flowing differently. So think about if I had a stack of just loose paper on top of my desk. I put my hand on top of that and I start moving it. Some of those sheets of paper are going to start moving, especially the ones closer to the top. But the entire stack is not going to move as one. Instead, each sheet is going to be able to kind of slide over a sheet below or above it. And this is how plastic flow works within ice. When we're looking at the chemical bonds of ice, we see that the bonds are stronger in a sheet than they are between sheets. Just like my paper, the bond in a sheet is much stronger than the bond between sheets of paper. So like I can slide that stack of paper and the pages are going to slide one on top of another. This is how plastic flow works within ice. But the other way that glaciers can flow is having just the entire body of ice slip all at once. This one is less common than our plastic flow. It generally happens on smaller glaciers. But regardless of the way in which our glacier is moving, whether it's plastic flow or the entire glacier moving, we'll see that because it's putting so much pressure on all of the ice at the bottom, that the ice at the top of a glacier is under really low pressure. Because of this, it's going to behave very similar to a brittle solid. So think about like peanut brittle. If you put a little bit of pressure on it, it's just going to snap. So when we're looking at the uppermost layer of our glaciers, this is called the zone of fracture. Because it's under so little pressure, it's going to be really brittle and it's going to start breaking or cracking. And all of these little cracks, I shouldn't call them little. Sometimes they could be hundreds of feet wide and thousands of feet deep, but these cracks are called crevasses. And you can see them here on this image on the right. Regardless of the type of glacier, we'll see that all glaciers are moving. They're just moving incredibly slowly. But occasionally we'll have really rapid advances, which we call surges. So instead of moving maybe a few centimeters, it might move several feet within a day. But if we're looking at our valley glaciers, the ones that are stuck in a valley in mountainous areas, we're going to see that the flow rate is different depending on where we are in our valley glacier. If we're at the very center of it, in the very center of our valley, this is where the glacier is going to move the quickest. Along the edges of the valley, where it's in contact with the mountains and all these rocks and valley walls, it's going to slow down glacial flow. So if we're looking at our glacier, right along the middle is going to be the fastest flow rate. But along the edges of our glacier, in our valley glacier, these are going to be slower because it's dragging against these solid rocks, which are going to slow it down. One of the things we care a lot about with a glacier is its budget. And a budget has absolutely nothing to do with money when we're talking about a glacier's budget. Instead, a budget is it accumulating snow and growing, or is it wasting away and melting? So it's just telling us whether our glacier is getting colder and larger, or getting warmer and smaller over time. But looking at the budget can be tricky. We can't just look at it in a single year, because every winter when it's colder, we're going to have glaciers getting larger due to that winter snowfall. But each summer we're going to see that our glacier is going to melt a little bit because it gets warmer in the summer, and it's going to melt that solid ice back into liquid water. So instead of just looking at a year, we have to calculate our budget over multiple years. We want to look at multiple winters where it's gaining ice and multiple summers where it's losing ice. And we're going to see that we gain and lose lose ice in different areas of our glaciers. So the higher mountainous regions over our valley glaciers, this is our zone of accumulation. This is where we're going to get more snowfall. It's higher in elevation, it's colder, so when there's precipitation, it's going to come as snow, and it's going to accumulate there over time. But as our valley glaciers move downwards down the valley, along the bottom is called our zone of wastage. This is where the glacier is going to get thinner, and it's going to melt more easily. So we call this the zone of wastage, because it's where the glacier is wasting away or melting. But in this zone of wastage, if we have a lot of crevasses, those really thick kind of cracks in the ice, it can cause what's called calving. And this is where we're going to have glaciers losing chunks of ice that are going to create icebergs, which we can see in this uppermost image. And it was an iceberg, just a broken off chunk of glacier that doomed the Titanic over 100 years ago. So again, with our glacial budget, we just want to know, is it growing or is it melting or wasting away? So when we're looking at our glacial budget, it's just either a balance or a lack of balance between growing and shrinking in size. So if we're looking at our glacier, again, over multiple years, and it is accumulating more ice than it is wasting or melting away, we're going to call it a glacial advance. That glacier is advancing or growing larger in size. Another possibility is where we have an equal amount of growth and melting. In this case, our accumulation and our wastage of ice cancel each other out, and we call this a stationary terminus. It just means that the glacier isn't growing, it isn't shrinking, it's staying stationary or in one spot. But unfortunately, what we're seeing worldwide right now due to climate change is that we have a lot more wastage than what we have of accumulation. We're having more ice melting than we're having ice accumulate. And this is leading to glacial retreat. We're going to see that the glaciers are retreating, they're melting and becoming smaller in size. But even if our glacier is retreating and growing smaller in size, that ice is still going to be flowing downhill, because no matter how small it gets, gravity will always affect it. Unfortunately, one of the things that we're seeing right now is that most glaciers worldwide are retreating. They're wasting away and they're melting at rates that humans have never seen before. I spoke a few slides ago about how for the last 2.5 million years, Earth has switched between really cold and really warm periods. But the issue today is not the fact that we're a warm period. The issue is how fast we are warming up every year. And glaciers are extremely sensitive to temperature change. Think about having a glass of ice water. Within maybe 5 or 10 minutes, the ice can melt once we pull it out of the freezer and into room temperature. And our glaciers on this planet are doing the same thing right now. They're in a much warmer environment, so they're melting very quickly. In this image, we're looking at the Columbia Glacier. On the top, the image is showing us where the glacier was in 1986. So all of this light blue area is where we have solid, really thick valley glacier. But the bottom image here is the same area in 2014. So here it is, less than 30 years later, and we can see how much smaller our glacier is. It no longer goes down this valley at all. It just stays in these really high elevations. So almost every glacier that we have on our planet right now is melting at a rate we have never seen before. And all of this is due to climate change, specifically because we have added so many fossil fuels into our atmosphere.